Today's talk, porting Erlang OTP to exotic platforms, what it's really all about is world domination. World domination for Erlang. So for various reasons over the past, I don't know, 6, 7 or 8 years, I've found myself in situations where I've had to build Erlang on platforms other than those on which one would normally find it. So, you know, most of us are used to downloading the Erlang kits from Erlang Solutions or wherever and installing them on our Linux boxes or on our Macs or on our PCs, as is the case with me from time to time. But for various reasons, I've had situations where customers have wanted to use Erlang on other platforms, or possibly friends or colleagues have wanted some help to get some sort of Erlang-based application going on another platform. So for better or worse, I've found myself learning possibly a little bit more than I really want to know about some of the inner workings of Beam and how to get that going on some possibly quite exotic platforms. So contrary to what Francesco said this morning, we're not necessarily talking about mainframes here, although possibly in the future that will be, you know, the final bit in the world domination for Erlang thing. But some exotic, slightly different Unix platforms, HP's legacy OpenVMS operating system platform and things like that. So what I'm going to talk about is my experiences of doing those sorts of ports, the sorts of things you've got to watch out for, the sorts of things you encounter, various kludgy, hacky workarounds, so on and so forth. So that's nicely summarised the abstract. A little bit about me. I've worked in the software industry now for 22, 23 years. Vast majority of that time has actually been with HP, Hewlett-Packard, and I just left them late last year to go and work for a little startup which, as I'll come to shortly, has managed to license a whole pile of intellectual property from HP, and we're looking at taking that forward, enhancing it, adding more good stuff to it, including Erlang, and having all sorts of fun. Okay. So introduction, the company I work for these days is called VMS Software Inc. And the intellectual property that we've gotten off of HP is an operating system called OpenVMS that was originally developed in 1977 by what was then Digital Equipment Corporation, affectionately known as DEC. Now DEC were bought in the late 90s by Compaq, and Compaq was suddenly bought by Hewlett-Packard, if you know your IT industry history. HP, a couple of years back, actually on my birthday in 2013, decided basically that they were going to pull the plug on the OpenVMS operating system. That caused a number of ructions, and my boss, the smaller guy in the photo over here, Eddie, worked tirelessly to convince HP that, you know, he could set up a company and we could take over the ongoing maintenance and support and development evolution of the OpenVMS operating system. So Eddie succeeded in that desire. And to date, we set up the company 31st of July 2014, and to date we've got about 35 staff, and we're probably not going to grow to any more than about 100, looking to double in size this year. Okay, so OpenVMS, anyone here ever used OpenVMS? Oh, good to see. Okay.
For 18 years.
Right. So as I said, OpenVMS originally developed in 1977. It's a totally non-Unix-like operating system. It would look like an alien world to anyone who is familiar with Unix and not with anything else. So totally proprietary. Key things about OpenVMS were sort of fairly unmatched reliability, stability and so forth. There was actually an interesting email discussion going on amongst some of the old VMS brigade just before the talk here, talking about some of the uptimes they've got. And I mean, there are systems, I recall there's a system somewhere in the Netherlands, it might be at the police station or something, that hasn't been rebooted for close on 20 years. And in terms of security, which is another big feature of the operating system, so only 38 vulnerabilities reported within 37 years. Now you compare that to the likes of Windows or Unix or whatever, how many vulnerabilities are reported every week. So we're talking about an operating system that's had 38 significant vulnerabilities reported in 37 years. There's a lot of users out there, so the size of this business is not really enough for a company like HP to be too concerned with, but from our perspective with our new company, VMS Software Incorporated, there's more than enough business for us out there, even with the existing customer base, and we hope to grow that and develop it further. Operating systems used across the board, all the major industry sectors. So just very, very quickly, brief timeline. As I said, the operating system originally developed around 1977 by Digital. purchased in 1998 by Compaq, who in turn purchased by HP. And as I said, on my birthday, 5th of June 2013, HP effectively announced the end of life of the operating system. Thankfully, we've now got the new company to take it forward, and there's a lot of happy customers because of that. Okay, so enough history, and on to some Erlang related stuff. So first up, what I want to do is just talk a little bit about existing implementations and maybe not so exotic ports of Erlang. Then maybe just a quick refresher course. How many people here have built Erlang from sources? Okay, cool. So I'll go through that, but very quickly in that case. So just a refresher course on how to build Erlang from sources, and then we'll start talking in more detail about some of the issues you face if you're going to try and port that code to work on some alien platform. Okay, so existing implementations and reasonably well-known ports of Erlang. Obviously, you can go to Erlang Solutions and download the latest release of Erlang for your favorite Linux platform or whatever, Mac OS and Windows. Over the years, there have also been a number of other ports, of course, to various platforms. I mean, FreeBSD, as I recall, WhatsApp run Erlang on FreeBSD. True64, that was another Unix operating system that was effectively stopped by HP that came from Digital Equipment Corporation. Very good operating system, actually. And a few other bits and pieces. There are a few other ports over the years of Erlang to various operating systems, some real-time operating systems, and now much less fashionable versions of Unix such as IRIX. Some of the ports that I've been involved with, there's a few that I won't list there. I only like to list my successes as opposed to my failures. And these range, as I said earlier, from anything where friends or colleagues needed some help getting Erlang going on some other platform where it wasn't currently available, as was the case with AIX. We needed to get RabbitMQ working on AIX for a proof of concept. That was relatively easy. I mean, the bottom line is really, as long as you've got, the GNU C compiler, GNU make, autoconf, and other bits and pieces, you probably can just about build Erlang on anything that's got those things on it. So it's not quite that simple, and I'll come to that later on, but you're essentially going to get probably 75–80% of the way if you've got those GNU tools at your disposal. So we did a quick and dirty port of AIX, as I say, for a proof of concept. It was enough for the proof of concept. It still had some rough edges. HP UX, Titanium, in my time with HP, the HP printer group wanted to use RabbitMQ again for a number of projects that they were working on. So we did a fairly good port, a fairly complete port of Erlang to HP UX on Titanium. Titanium being an Intel processor type that really only HP developed servers for. True64, well, that was easy. I was bored one evening and just wondered how hard it would be, and it was pretty darn straightforward. The big one from my perspective over the years has been getting Erlang working on OpenVMS. The first port I did of that took me a little while and probably caused me some serious liver damage. Subsequent ports really don't take very long at all. It's just a case, obviously, of replicating the changes, and longer term, I guess what we want to do is look at trying to get some of those changes pushed back into the main code. Essentially, that started again. I wanted to get an advanced message queuing implementation working on OpenVMS, and I knew the guys at RabbitMQ, so it was a logical choice, except for the fact that it was written in Erlang. So I was a bit sad and depressed about that for a while, and then a good friend of mine basically dared me to try porting Erlang to OpenVMS, so that was like, game on. And I'm happy to say we got there in the end. Quite a few challenges that I'll discuss shortly. Okay, so a quick refresher for those who may not have built Erlang on Linux or whatever. Essentially, the half a dozen or so commands that I've typed there, and you could obviously combine the g unzip and the tar xvf, you could combine them into one command, so you could chop one of them out. But essentially, that's kind of it. Assuming you've got a reasonably well set up Linux system, so we're going to do an install of all the GNU tools we need with the apt-get install build essentials. We're going to use our favorite tool to download the sources, unpack them, type configure, type make, go and get a cup of coffee or something, come back, and magic will have happened and it will have built, and we go and do a make install, and then we can go and do cool stuff with Erlang. All seems pretty easy. The key thing here is you know, the whole GNU make thing where you run some configure script and it generates make files, it generates a header file that deals with platform dependent things and so on and so forth. Now when you run that configure script, as I say, it's going to generate for you a series of make files that are needed to build all the bits of Erlang and OTP. It's going to generate for you a header file which helps to try and deal with all the platform dependencies, little subtle differences between C runtime libraries across Unix and Windows and wherever. But at the highest level, what it does is it basically has a bit of a look at what you've got installed on your Linux system, and if you don't supply any options to the configure script, it's probably going to come back to you and say, well, you don't appear to have some of these things installed, I'm not going to build those. So I have no particular interest in Java, so my Linux server didn't have Java installed. I obviously didn't have Unix ODBC installed, and I don't really like WX widgets. I'm a bit like Mike when it comes to that sort of thing. And so the configure script didn't find those things. I hadn't installed them, so it's just telling me here I'm not going to build Erlang with this stuff in it. And I'm not going to generate the documents because you haven't got the right stuff for that, but that's okay because I never read the documents anyway. Okay. At a high level, that's what configure is going to do. But if you actually have a bit of a look at the configure script in more detail, it provides a heck of a lot more flexibility than that. You have huge control over how Erlang is going to get compiled, how it's going to get built, what features are going to be included, what features are going to get excluded. I'm not going to click on the link there, but take my word for it. If you type, you know, /configure -help, you'll get like 2 or 3 pages of output of all the different options you can specify to the configure command, all the environment variables you can define before you run the configure, and these things will control various attributes of how Erlang ends up getting built for you in your environment. If you don't want to build Erlang with SSL support, you can tell the configure script to leave that out, for example. Okay, so like I said, one of the things that gets generated by the configure step is a config.h file. This is standard GNU build stuff. And that config file basically just contains a whole pile of C preprocessor directives, you know, #if def this Linux platform, then include these headers, define this macro, so on and so forth. Not exactly rocket science, but that's quite a key component when you're coming to try and port Erlang to another platform, because chances are you're going to have to either manually create one of those or take one that's been generated and tweak it slightly for your platform, for your target platform. As I've said here, config.h is designed to deal with many of the platform dependent bits and pieces, header file differences, differences in C runtime library, so on and so forth. But, you know, as I say, on a Linux box, a few commands and a little bit of time, you can build Erlang really easily. So now we want to go and port Erlang to a new platform, some alien world, OpenVMS, mainframe, whatever. I'll talk mostly, I guess, in VMS terms. Doesn't matter. The approach that I describe probably largely the same and will help you to solve the problem on whatever platform you like. So let's look at the scale of the problem. I think this is like a bridge over the Hoover Dam or something, which is probably a fairly big problem. Erlang, it's an appreciable code base, right? You've got roughly 500,000 lines of C code, so there's a lot of C code in Beam. There are other bits of C code for other programs that make up the entire application suite. In addition to that, there's about 2.3 million lines, depending on what version of Erlang you're looking at, about 2.3 million lines of Erlang code. And that's including bits and pieces like test suites and so forth, which aren't all that relevant, I guess, at runtime. But the bottom line is there's you know, it's a lot of code. The main challenge when you're looking to build Erlang on a new platform is obviously going to be that C code. But as I'll point out in a few slides from now, there are also things that you potentially have to deal with in some of that Erlang code as well. So the main components that need to be ported from a C code perspective I've listed here. Obviously Beam, obviously we need the virtual machine. Without that we're not going to get very far at all. There are other executables in the kit as well. There's the endpoint mapper daemon, there's the Erlang compiler, eScript, and a few other bits and pieces. You know, we pretty much need to build all of these guys. Also, depending on the options you chose when you ran that configure script, for example, you probably also have to build a few shareable images. So if you're including OpenSSL, for example, support for SSL in your Erlang build, you're going to find the way the Erlang library for SSL works is it's doing calls into the OpenSSL APIs and so forth, so there'll be a few shareable images that get built. And as I put there in blue, I mean, you know, it's probably no huge surprise to anybody, but Beam is going to be the most challenging piece of code to port because it's got all the hairy bits and pieces in it around SMP support and threads for the scheduler and, you know, all this sort of nonsense. So it's going to be the most challenging one. Good news and bad news. This is me doing my hearing absolutely no good with a jackhammer breaking up concrete. The good news in this particular case was the concrete was actually fairly easy to break up. But there's good news and bad news. I mean, the thing about the Erlang code is it's been around for a while now and it's actually pretty darn portable C code. So as long as you've got a fairly standards compliant C compiler and your C runtime library is you know, fairly standards compliant, chances are you're going to be able to compile Beam and those other bits and pieces, right? It uses standard GNU tools, as we've seen, for doing the build. Well, that's great if I'm running on Linux or Unix where I can use those tools, but what if I'm in some sort of environment where, like OpenVMS or a mainframe where I just can't do any of that? Okay, so that's kind of bad news. Good news is the code is portable. Bad news is some of these alien environments don't have stuff that you can use to build the code. And like I say, there are also issues that you need to consider in the OTP libraries themselves. Typical sorts of things that you need to think about, issues and challenges. What options should I use? So I'm going to port Erlang to my new alien world and everything's going to be good and ultimately we'll achieve world domination. What options should I use when I do that configure step? In terms of the C code, sorts of things that invariably cause challenges are threads, symmetric multiprocessing, a few other bits and pieces. It's also interesting when you do these ports that you sometimes find, although I have to admit I've only found one, anomalies, otherwise known as bugs, in the Erlang code. And as I say, you've also got to watch out in the OTP code. And I was talking to Robert about this earlier, where if you actually do a grep through the OTP library code, you'll find quite a large number of OS type and OS CMD calls. Okay, so these are situations, and I've got some on subsequent slides, where people in the OTP libraries, there'll be some sort of case statement. If the operating system is such and such, then do this command. If the operating system is such and such, then do this command. You know, that's, if you're then porting to a new platform, you potentially have to go and change that Erlang code to include the appropriate case statement for your platform. So back to our configure script. Just wanted to list here some of the more important options, you know, when you're actually thinking about porting Erlang to some exotic alien environment. Some of the more important ones, and why they're important is because they either add or subtract complexity, right? You can kind of figure without really thinking about it too hard that disabling threads is going to equate to simplification. Disabling SMP support equates to simplification. So the way I quite often will approach these problems is, in the first instance at least, I'll try and keep things as simple as possible and leave out all that stuff that I know is going to cause me great pain and suffering and further liver damage. So, you know, you might like to do a build with disable threads, disable SMP support, things like that. If you know as well, for example, that like OpenVMS doesn't support kernel polling, be absolutely no point in you know, running configure, assuming I could run it, with kernel poll enabled. It's just not going to work. These tend to be the ones, as I say, that are most relevant when it comes to adding or subtracting complexity from your build. And what I'll tend to do is try and build something simple first, get it working, that's a big confidence boost, big party, everybody's happy. Then I'll look at adding in some of the more complex bits. So just some examples of configure commands that I've used with some of those projects that I referred to earlier. AIX, fairly simple. As I say, I wanted to keep it simple, so I didn't enable SMP support, even left out SSL, which is maybe a little bit naughty, things like that. But for the most part, just kept it fairly simple. OpenVMS, well, like I said before, OpenVMS definitely doesn't support kernel polling, and it doesn't support the SCTP protocol. And I don't even want to think about hype. That's just going to be nasty. So the initial configure, though, in this case, because like I say, OpenVMS doesn't know anything about a bash script, so it can't run the configure script. So I'll talk more about what you do there, but essentially the approach I take is to run the configure on another server and then take across a modified version of the config.h and modified build procedures and so forth. SSL is actually very easy to add in later. SMP support and thread support is a little bit harder to add in later. For the record, I just thought, just out of interest, you know, like I said, the Erlang code base, the C code and so forth has been around for a long time. It has been ported over the years to quite some number of Unix-like platforms and so forth. And as a consequence of that, if you do a search through the code, looking at various preprocessor directives in the C code there, I found that there are a total of about 900 plus different C preprocessor directives in that Erlang C code. You know, these will be things about for a particular platform or whatever, or a way to build the code in a certain way and so forth. There's a lot of macros, there's a lot of flexibility that you can specify in something like that config.h file about how Erlang gets built. Right. And the reason for the picture of the bear is that there's a lot of choices when I go shopping. Okay. So let's just look at some examples of some of the stuff that I'm talking about. So for example, SMP and CPU topology. Now, on most self-respecting Unix platforms, for example, you can do a call to the sysconf function to find out how many CPUs there are on the system, how many of those CPUs are active, and things like that. What you find, however, when you go to port to HPUX is that you don't have a sysconf function. Right? Well, this is one Unix implement. Even VMS has a sysconf function, but HPUX, it seems, does not. So this particular function here, it's CPU info update, which determines, you know, a bit of the CPU topology, how many CPUs are on and how many are configured and so forth. You need to go and add some code on HPUX using assorted preprocessor directives. You need to go and add some HPUX specific code to determine that information. Not a big deal, but you know, these are the sorts of things you have to contend with. Threads, I always get a little bit confused in Erlang about how threads work, so I thought I'd steal some words from a talk that Robert did a couple of years ago on that. I mean, I think the key thing from my perspective is, you know, the asynchronous thread pool is good because it helps us with making I/O more efficient and things like that. So we really want this stuff built into our Erlang port to make it go better. But threads are evil, nasty things. Fortunately, however, from a portability perspective, most good operating systems have fairly complete and decent pthreads libraries. And what you tend to find, there'll be a couple of areas where you may face some challenges here with threads: missing functions and thread stack size. Missing functions usually equates to this guy here, to be honest, pthread sig max. Pthread sig max is basically the thread-safe equivalent of the standard C runtime function sig proc mask, I should say, not max, mask. If you read the man pages for these functions, it kind of almost infers that on most platforms this guy is thread-safe. So if you don't have the pthread function, just use this one. So on VMS, that's what I did, and I put an appropriate comment that I'm crossing my fingers and toes that nothing bad happens. Per thread stack size. So by default, operating systems set some limit. You can control it via our limit on Linux or Unix or whatever. But by default, there will be some limit imposed on the stack size, some default limit imposed on the stack size or default value on the stack size for each thread. So when I was feeling quite happy with myself that I'd managed to compile and link Erlang on OpenVMS with supposedly with SMP support and everything was great, and I was feeling very pleased, it wouldn't even run. I fired up Beam and it complained that it was out of stack space. So I thought, well, that's kind of interesting. So I did a little bit of digging, and in the end I wrote a little piece of code to tell me, well, so what is the default stack size here? And on VMS it was telling me that, you know, it was basically allocating 40K. About 40K of memory for the stack size was being allocated. I thought, well, that's interesting. What happens if I run that on Windows under Cygwin? What happens if I run it on Ubuntu? Ooh, much larger numbers. So the conclusion was that by default on OpenVMS, the amount of space, stack space that's being allowed for each thread is way too small. Of course, the guys that wrote Erlang are pretty smart guys, and when I actually then went and had a look through the code, I discovered that they'd provided a way to deal with this. And all I needed to do was modify the function that I've highlighted up there in the ethread.c module. I should point out actually that all this Erlang, this C code that you know, within Erlang is very nicely modularized, and it's actually quite easy to find stuff that you might need to change. But as I say, the developers had obviously encountered this problem before. Maybe they were running, you know, ported Erlang to some device that was memory constrained or whatever, and it provided facilities for you via a macro, which I've specified there, to actually say what stack size should be used when you spin up a thread. So after I discovered that and put an appropriate entry in config.h and rebuilt, everything was happy, mostly. Rather ironically, it turned out that that 40K value wasn't too far off the mark, and I could quite happily get by with just 64K. Polling. Well, the interesting thing here is that, you know, if you're developing any sort of network application using Erlang, or if you're using RabbitMQ, React, or things like that, which I commonly do use, sockets are quite often toggled from blocking to non-blocking. And there are two ways you can do that, either using the FC, well, there are actually more than two ways, but two fairly common ways, the FCNTLC runtime function and IOCTL. And you need to be a little bit careful because on some platforms, the FCNTL function does absolutely nothing. It will not change the behavior of the socket at all. So you need to be aware of what your platform does and doesn't do in terms of whether one or other of these functions works, and you need to make sure, you probably have to include more preprocessor directives to make sure that these macros set blocking and set non-blocking get defined appropriately to make sure that you get the expected behavior on your sockets. Within Erlang, polling could occur on sockets, pipes, whatever, you know, various types of I/O descriptor. On OpenVMS, functions like select and poll that you use for polling sockets and so forth only work on sockets. So as a consequence of that, porting Erlang to OpenVMS, I basically had to implement my own versions of functions like select and poll to deal with the polling of those other types of descriptor. And that's far from ideal because that basically means that Brett has to sit down and write some grubby hack that probably isn't going to perform well because he's grumpy that he had to do it in the first place, and it will be some really rough and ready implementation. But now, since I work for the company that has total control over the OpenVMS operating system, I'm going to see about getting that behavior changed. And then we can throw away my grubby hack. Okay, now like I said earlier, just dealing with the C code itself, which is certainly the bigger part of the problem, it's not the only thing you have to worry about. You also have to think about the Erlang OTP library code, and in particular OS type and OS command calls in the library code. Luckily they're easy to find, and generally speaking they're pretty darn easy to fix. So case in point here, so what's the module we're looking at here? Okay, so initializing memory monitoring. As you can see, there's a case statement. We're doing an OS type call, and there's a case statement. You know, if it's Unix Darwin, then we're going to return false and blah, 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 blah. So very easy to add in an entry for Unix, HPUX, for example. Not a problem. I just made a note that in that particular file there are a few more instances of this sort of thing. But, you know, you're porting Erlang to a new operating system. Be aware that you may need to do this sort of stuff. So, for example, I don't think I realized this at first, and I was trying to run React and it was mostly working, and then it was falling over in a screaming heap when it tried to kick up some of this monitoring stuff. And that was kind of one of those, you know, Homer Simpson duh moments. And I suddenly realized exactly what the problem was. Another example of this sort of thing, in this case, disk space monitoring. You know, it's kind of quite interesting that illustrates here as well. Again, easy to go and put an entry in for HPUX, it's not a problem. But what's kind of intriguing here is that, you know, you suddenly have this realization that even things like the output of a df command or the syntax of a df command or even, you know, the path you use for the df command can vary from one Unix/Linux implementation to another. Okay? And, you know, one thought that occurred to me for some of these more common things, like in, you know, disk monitoring or memory monitoring, maybe it would actually be easier to build something into Erlang itself that you could just call instead of having something that, you know, really is a little bit kludgy. Also, just note there that on Windows, this is actually done using a port program as opposed to running a command. And another point to note there also, on Unix, starting up a sub-process to do something like this is generally a fairly lightweight operation. On OpenVMS, creating a sub-process is actually very time-consuming. So as part of my OpenVMS port, I'm always looking at these sorts of things saying, do I really want to do this? Because it's going to actually take time. Operating system flavor. So you noticed on those 2 or 3 previous slides where in the case statement I'd added Unix, HPUX. The way in which Erlang figures out at runtime what the platform is, there's a little function called OS flavor lurking down in the bowels of the code somewhere in a file name called sys.c that calls the C runtime library uname function and converts that to a lowercase or something or other like that. And that's basically that HPUX thing. But there's a catch here, and I lied on some of those previous slides. On HPUX, uname returns HP-UX. Now, if you recall from that Erlang OTP code, it's expecting the flavor to be represented as an atom, and atoms cannot contain hyphens. Yes, you can go and do messy things like stick quotes around them, but that would have resulted in ugly code. So in my HPUX port, I basically did something really a little bit dirty, which is what's highlighted there. I said basically if I know I'm on HPUX, then I'm just going to return the flavor as HPUX. You know, why even bother doing the darn call? I know what I'm running on because that's what I was compiled on. So that was a little quirk that actually took a wee while to figure out. You know, what's the deal? This hyphen thingy seems to be causing grief all over the show. Like I said before, porting the code, porting any application sometimes uncovers bugs that had not been noticed previously. In this particular case, it's an incredibly minor one, but it's kind of another one of those little quirks about how things have mutated and changed with the C runtime libraries over the years. On most Unix platforms, you will have either map anonymous defined or map anon defined, and on some platforms you will have both, but on some platforms you will only have one. These things are all to do with memory map files and things like that. So what this code is doing is figuring out basically how it's going to do memory mapping of files and so forth. So basically this is a bug when I was porting to HPUX. This code would not compile because on HPUX the map underscore anon macro is not defined. And as you could see, they'd actually been inconsistent in the code. So, you know, totally trivial to fix. So bouncing around a little bit and back to OpenVMS, feeling really, really happy with myself, went out and bought a dozen beers to celebrate. Things appeared to be working really, really well on OpenVMS, SMP support, you know, all cool, good stuff. But what I was noticing was when I went to fire up the Erlang shell, it seemed to take some disproportionately long time to actually, you know, give me the little Erl prompt. Well, that's interesting. Didn't really think too much of it, typed a few commands and it seemed to do sensible stuff, so I was happy. And then just for no particular reason, I don't know why, I went and monitored the CPU. Ooh, you know, there's one process running on this machine and it's chewing up 100% of one CPU. Well, that can't possibly be good. You know, I know there are little things spinning around in Erlang doing stuff, but seriously, 100% CPU? I don't think so. So trying to debug this stuff with some sort of symbolic debugger is a bit of a pain, but thankfully on VMS what I could do was profile the code. And what that told me was that I was spending like 99+% of my time sitting in that function there, sys main thread. Well, that's interesting, and I had a look at that function. It's fairly short, doesn't really do much. It's quite a tight loop that just kind of starts up a pile of other stuff, and then it goes into a loop and twiddles its thumbs, waiting for some sort of interrupt or whatever to be received. The way at which it twiddles its thumbs is it basically does a select call with 0 or null for all arguments. So people who are familiar with C or C runtime library, select call like that essentially is a way of sleeping in an interruptible fashion. Okay. Problem I discovered was that that particular select call on OpenVMS just returns immediately. It doesn't like having the last argument in particular. It doesn't like having that null, which on Unix basically means sleep forever unless you're interrupted. On VMS, it says, I don't like the look of this, and returns immediately. And the net result was my process was just spinning around and around and around within that loop. So again, easy to fix, but there are just these subtle little platform differences that come out and bite you. A few other things. Not all operating systems support a Unix-like fork function. Thankfully, fork is not terribly important within the Erlang code. And in those situations where fork is used, it's kind of optional, and you can compile to use the vfork function, which does sort of a little bit less. You can compile to use that instead. File system differences can actually be the real nasty big problem to deal with, to be honest. So if you actually have a look at my VMS port, most of the work I've done will have been in the file driver as opposed to anywhere else. Not all file systems are created equal. If I'm talking here about what characters are actually allowed in file names, how long can file names potentially be, what do path separators look like, is the file system hierarchical or not? All of these sorts of things. This can be a real nightmare area to have to deal with. The saving grace for me with regards to OpenVMS is that modern versions of OpenVMS allow you in the C runtime library to specify path names and things using a Unix-like syntax. If I couldn't do that, I would still be working on the port today, most likely. It would be hellishly complicated. And just thinking of that, if I think about it with Windows, I think there's some code in there to deal with these things on Windows. But as I recall, Linux on Windows is built primarily under Cygwin, and that helps you get around a lot of these sorts of issues as well. Hype. So it was interesting hearing the talk this morning, and I think it was Joe saying that just-in-time compiler for Erlang isn't too far away. So Hype, I guess, was kind of the forerunner of that, and there was a lot of work done at Uppsala University over the years since the late 90s on Hype. So basically allowing you to compile on the fly, at runtime, compile your Erlang code into native instructions and so forth. Porting that is non-trivial. If you're porting to a platform where it's one of the supported processor types, you might be lucky. Otherwise, you're probably going to have to learn some assembly code and get very frustrated. Good thing is you don't need Hype. It's not all that widely used. It'll be interesting to see how the just-in-time compiler goes down. I'll be quite interested to see that. There's some good papers on this stuff, by the way, as well there, links. Don't panic, yeah. So this slide basically illustrates the general approach that I take if I'm building Erlang in an alien environment, and by an alien environment I mean an environment that's not necessarily particularly POSIX-like in terms of bash shell, GCC, autoconf, make, all of that sort of nonsense. Assuming I haven't got any of those things, this is basically the approach I will take. Okay, so what I will normally do is I will build Erlang on another platform that is supported. Ubuntu Linux tends to be my favorite, but just pick whatever works for you, doesn't really matter. Carefully examine the config.h, make any changes to it that may be appropriate to the platform I'm trying to port to. Maybe the platform I'm porting to doesn't have a specific header file. Maybe the C runtime library doesn't support some function or another. So make those changes to the config.h file. When you do the build, capture a log of all the output, all the compile commands that are executed and so forth, and you can incrementally convert that back into something that will actually compile the code on your target platform, and then incrementally go through resolving compiler errors, linker problems, so on and so forth.
Any particular reason not to try cross-compiling?
That would be another possibility for sure. If you had that opportunity, that would work, yeah. This may sound a little bit tedious, but it actually doesn't end up being that bad. And also sort of once you've done it once, you've got all the machinery there, and it's not so bad second time round. But yeah, there's no reason why you couldn't do that. And you know, of course, the compiled Erlang code, those beam files are of course portable, right? There's no issue there. Okay, yeah. Cross your fingers, test and rework. So just very, very quickly, because we'll run out of time, but really, you know, I do a lot of work with things like RabbitMQ and React and a few others. Porting those guys, to be honest, in some ways, you've got to deal with the same issues. Particularly, say, something like React, where it's not 100% Erlang, okay? So if you look at something like Rabbit to start with, Rabbit is 100% Erlang, but it suffers from those OS type, OS command situations where within the Rabbit Erlang code, the guys are going off and running operating system commands. So we've got Erlang working happily on OpenVMS. We now want to run Rabbit. We potentially need to go and do something like I've highlighted in red here for some of this stuff. Again, as I say, it would be nice if Erlang actually provided the functions that would just, you know, callable and do that. Another example in RabbitMQ, in this particular case, I'm executing 2 OS commands, which is just to prove a point. Like I mentioned before, creating sub-processes on OpenVMS is not very efficient, so this is, you know, not going to be a particularly performant operation by any stretch of the imagination. React is certainly not 100% Erlang. You've got the SpiderMonkey JavaScript engine, which up until recently was actually quite an easy piece of C code to port from one platform to another. Now they seem to have gone and changed all those .c's to .cpps, which, you know, terrifies the heck out of me. They've also got the LevelDB and Bitcast backends. Bitcast is quite portable. There are some quirky bits in there, but generally it's not too bad. LevelDB, it's you know, my arch enemy. It's an evil pile of highly optimized C++ code with just about every optimization you could think of. Atomic operations, inline assembly code, platform-specific use of built-in functions, and so on and so forth. If there's a way that code can be optimized, it's pretty much been done. Porting that can be really quite frustrating. There's not too much use of OS type and OS command in React, but again, you know, something to watch out for. So just very, very quickly, some results. So my main focus has been around the OpenVMS operating system, and generally speaking, I'm pretty happy with what we can do there. You know, we can run up some pretty major apps that stability is reasonable, performance is reasonable. Got yours, RabbitMQ, React. I've had most of CouchDB and things like that working as well. As I mentioned earlier, you know, there are some kludges that I've had to do around functions like poll and select, and also the current implementation of the TCP/IP driver on OpenVMS isn't as crash hot as it could be. It's a little bit slow at times. So there's some work to do, not just at the Erlang level, but also at the operating system level to make life better. So if you're familiar with RabbitMQ, for example, you know, the sorts of numbers I'm talking about here, 19,000, 20,000 messages per second on a reasonably capable piece of hardware. I mean, I'm probably going to be able to pull at least twice that on my laptop, for example. Okay, so performance, average. I'm happy. I'm happy with where things are at. Could be better. No problems with clustering. This stuff just worked out of the box. Amnesia, clustering, all worked out of the box. No problem creating on OpenVMS a multi-node RabbitMQ cluster, a React cluster, whatever. Actually, the biggest problem was, you know, there are shell scripts in React or whatever to control administering the cluster, was just converting them into something that I could use on VMS. Summary conclusions. You've got a big pile of standard C code that you need to port to get Erlang across to some alien world. That code is well written. It's nice and portable code. If you've got a half-decent C compiler and C runtime library, you're not going to have too much problem. If you've got GNU tools for doing the build, then your success rate or your chances of success are going to be very, very high indeed. Don't forget that you might have to make changes in the Erlang OTP code as well as in the C code. Hype. Try to avoid it. And as I say, many of the same considerations to porting Erlang itself pertain to porting large and complex Erlang applications. particularly those that have, you know, bits and pieces in C code and so forth. Future plans from my perspective will obviously tidy up all the rough edges around the work that I've done to date. One of my key roles within VMS Software Inc. is sorting out our open source strategy, and you know, I'm very, very keen to see Erlang as being a significant part of that open source strategy. And I think that Erlang and OpenVMS are kind of a natural match in some ways when you look around the sort of, you know, similar design principles around fault tolerance, reliability, availability, and so forth. Alrighty, and whoa, questions? Yeah.
Have you ever tried to run on batch cluster or there's an EMS cluster?
Okay, so VMS runs on 3 architecture types, VAX, Alpha, and Itanium. Okay, so VAX, you won't find terribly much VAX around anymore, and to be honest, the C compiler would not do it. It would not work. Alpha and Itanium, yes, are done. So the current version of OpenVMS is 8.4, which is available on both Itanium and Alpha, and the compilers are comparable. So, you know, basically if the build works on one, it's a fair bet that it's going to work on the other, and it does. Okay, so I have run Erlang on both Alpha and Itanium, but not VAX. And I don't even want to think about that.
One other question.
Yes, sir.
VMS has version number on every file.
Yeah.
How do you do that within?
Yeah, so it's a bit of a mixed bag there. So in some cases that matters, in other cases it doesn't. But like I said before, the newer versions of VMS, when you initialize the file system, you have a choice about essentially what the file system supports in terms of file naming conventions, how long file names can be, all of this sort of stuff, mixed case, whatever. But more importantly than that is that the newer versions of the OpenVMS C runtime library are quite happy to accept Unix-style file names, and there are also a number of settings that you can specify on OpenVMS that control behavior, like whether there will only be one version of that file and things like that. Okay, so we can control it to that level. I mean, this, you know, what I've talked about here is kind of, there's a lot of detail in there that I've skimmed through. Yeah.
Were you doing your compilation with the native compilers or with GCC?
With the native compiler. So at the moment there is no GCC on OpenVMS. There's like an old version that runs on Alpha, but
right,
yeah.
But the reason I was asking is it'd be interesting to see what kind of performance differences you got. You could run GCC on Linux and cross-compile for Itanium.
You could. That would be an interesting experiment. It would be. My guess would be that the native compiler is probably going to be better.
Will it be significantly better? Question. Because you're going into some trouble in order to have that.
I am, for sure. Yeah. Interestingly there, the best code you get, the best code you get on VMS is actually out of the C++ compiler, because the back end for that on Itanium is from Intel, and I'm not even allowed to look at it, basically. But that will do the best possible optimization for Itanium. Yeah. Yeah.
Do you have any maybe second-hand information about embedded ports to RTOSS,
Oh.
DX ports, and similar?
Not off the top of my head, no. I mean, you might be better off checking with one of the Ericsson guys for that. I mean, it's been done. There's probably a whole lot of stuff out there in the field that, you know, maybe someone tweeted about or you know, just never told anyone about. But I'd talk to the Ericsson guys. Yeah.
Let's say you're done by porting Erlang to some exotic system, and how do you make sure that everything is fine? Do you perform some tests?
Okay. That just depends on how lazy I'm feeling, to be honest. Erlang itself has a very comprehensive test suite, so that's one approach. Similarly, you know, most good open source packages, so if I look at something like Rabbit or if I look at React, they also have test suites as well. So you know, you can give them a spin and see how you shape up. I mean, I haven't achieved perfection by any stretch of the imagination. But yeah, there's plenty of stuff you can use for testing it. Yep. Any more? Yeah.
What place is that?
That is Lake Pukaki in New Zealand. So I'm from New Zealand, so it's like, what, 4 hours drive from home, and that's Mount Cook in the background. Yeah. Cool. Alrighty. Thank you very much.